Okay, let's get started with our class this morning, afternoon, evening, whatever it is, whatever time of the day it is for you. And hope you guys are doing well. We are in 18.3 today, 18.3. Now, I had given you this work for last week, but things got a little hectic around here, and so I could not get to this video. But do not worry, do not fret. Pastor Awesome is here. I love the effects on this thing. All right, so quick review from last week. You don't have to write this down, just a quick review. Let me remind you to also make sure that you are sending your work. I have not gotten some work from some of you. I shall not call your names out at this time, at this video, but if you do not get me your work soon, your name will be plastered all over YouTube as a delinquent, someone who has not done their work. Okay, great. So keep that in mind. By the way, the rest of this week, I will be emailing your work to you. You could just do it on your iPad or computer, wherever you have, and send it back to me. And I'll give you all that information later on. Okay, great. So last time, I don't know what's going on with my voice. It's like one of those days when you have a thing in your voice that doesn't let you speak. By the way, my breakfast this morning is a nice, hearty Slim Fast. It says that it controls hunger for 4 hours. That's a lie, because I am going to be hungry in about 1 hour. Anyway, so last week we were talking about looking at ratios within right triangles, right? And we said that a right triangle is a triangle that has a what? Anybody? A right triangle. Good job. You guys are smart. And we looked at the tangent in a right triangle. And we said that the tangent is the ratio between the opposite and adjacent legs of the non-right angles in a right triangle, okay? So when we are talking about the non-right angles, we're talking about these bad boys right here, okay? And so each one of these angles here has several ratios that go along with them. And so the first one we saw was the tangent. And we said that the tangent is found by dividing the value of the opposite leg by the value of the adjacent leg within the triangle, right? At least for this angle here. And for this angle here, again, is the same. The opposite leg divided by the adjacent leg, or the value of it. And so the function or the formula for tan, okay, which is short for tangent, is the opposite leg divided by the adjacent leg, okay? And we did some of those last week. So let's say, for example, that the opposite leg over here is, let's say, 8.5, and the adjacent leg is almost as close to it. Let's just say it's 8. Okay, so our formula tells us that 8.5 should be divided by 8, and then you just divide that up and you will get your answer. So let's find out what that is. It should be about 90. Oh, let's see. 8.5 divided by 8. It's 1.06. That would be the ratio between this one and that one, okay? And so that is the tangent. Great. Now, that's what we did last time. I hope that in your worksheet 18.2, you were able to have that or understand that, okay? The only thing you were using was that formula right there. Great. Okay, so let's continue on today to bigger and better things. Today we're going to be looking at sines and cosines, okay? Sines and cosines. Now, these are two additional ratios that are found within a right triangle, okay? So we're just going to go through these quickly, and we'll do some examples, and then you guys should be able to work on 18.3 pretty easily on your own. All right, so here we go. Let me get this where we all can read it. Great. So, okay, girls, pay attention, please. No talking. I see you girls talking. Stop it. Sebastian, did I tell you I liked your haircut? Did you get another haircut? All right, that's good. All right, Joseph, stop playing around. Nope, we don't have time for that right now, Joseph. You can tell us the story later. Good job. Thank you. You're a good man. All right, so let's talk about the sine. Okay, the sine. Sines and cosines. The ratio, the sine is the ratio between the opposite leg of an angle, that would be a non-right angle, and the hypotenuse of the triangle. Okay, so let's look at this one first. This is ratio number 2 that can be found within a right triangle. Now look at this. We have, once again, the non-right angle, okay? It is not the right angle, non-right. This is the right angle. Okay, so we have this right angle here, and we're going to, the sine is the ratio between the opposite leg and the hypotenuse, okay, right there. So in the tangent, the formula is the opposite leg over the adjacent leg. But in a sine, or the ratio for the sine, we're looking at the opposite leg and the hypotenuse, okay? And so for this one here, once again, this angle up here, the opposite leg and the hypotenuse. And once again, the hypotenuse is the opposite side of the right triangle, so that's easy to find. Okay, so the formula for sine, the sine of an angle, is the opposite leg divided by the hypotenuse. Okay, that's the formula. All right, this is not hard, people. This is very easy. Okay, even my grandma can do this. Well, maybe no, she can't. She is dead. But anyway, let's continue. If she were alive, she could. Now, so let's find the sine for the 40-degree angle in the following right triangles. All right, so here we go. Okay, so here we have several angles. Let me just erase these so like that we can go through them ourselves. Okay, so we have the 40-degree angle is right here. And we want to find the sine for the 40-degree angles. Great. So our formula, which is up there, tells us what to do. Okay, so I want the opposite legs, which is that one right there. And I want also the hypotenuse, which is right there. Good. So I am going to divide 4.2 by 6.53. All right, that is the formula that we want for this triangle. All right, let's look at the second one. We have the 40-degree angle right there. Now, obviously, you could have done this with this angle as well, but the instructions told us that we're looking for the 40-degree angle only. All right, so let's see. The opposite leg right there, the hypotenuse is right there. So I am going to divide 2.94 by 4.57 meters. Great. And then the last one is right here. This is our 40-degree angle. I want the opposite leg, which is that one right there. And I want the hypotenuse, which is that one right there. Okay, in all of these, you just have to keep in mind that right where the right angle is, and it helps you find everything else. All right, and so now for the third one, I am going to divide 5.46 divided by 8.49. Okay, So these are just the, what did I do? Let me go back. Anyway, we'll leave it there. These are the formulas to finding the sine for these right triangles. All right, so once we do that, you will find out that each one of them will have, the answer should be 0.64. 0.64 is the sine for each one of these right triangles, okay? So that's easy enough. So that means that each one of these triangles are similar, okay? They are similar. This one, and this one, they are similar to each other. And similar means that their angles will be the same, and the ratios, okay, the ratio of their sides will be the same, which we have right here. Even though they are different sizes, they are similar. The only thing that is different is their size, okay? Great. Now, let's continue. You didn't have to copy all of that. Well, yeah, sure, why not? You can pause the video and copy all of it, and it will be good for you. Besides, you need some work. Don't tell me you're busy at home doing stuff. But Pastor, my mom has me cleaning the house. Wah, 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 wah. You'll be fine. It's good for you. Sorry, I had to take a drink out of my Slim Fast. I'm going to tell you something. It's not making me slim fast. It's not. Let's continue. All right, so a truth that you will find when it comes to the sine is this. The sine will always be the same for a specific angle measure. Okay, so whenever you have similar, basically what we're saying is that whenever you have similar right angles like these, or right triangles like these up here, and they have a 40-degree angle, okay, 40-degree angle, if their legs are the same ratio, you will always get the same answer for those particular triangles. So let's say we had another set of 3 triangles. That's not a triangle. That's a weird triangle. If we had another set of triangles here, right triangles, and they were all similar, and they all had a 40-degree, angle, they will have the same measurement, okay? So the sine will always be the same for a specific angle measure. So any angle, in this case, any angle that has a 40-degree measurement, the sine will be the same. Okay? So keep that in mind. So if in a problem you are given 3 triangles like the ones we have here, and you are told, look, they're all similar, right? They're all similar. And one of them has a 40-degree angle, and they're all similar, and they tell you what is the sine for all 3 of them. Well, and they don't give you the information for the other 2, right? They don't give you the angles for the other 2, but you know that they're all similar, and one of them has a 40-degree angle. Whatever the sine is for that one, it'll be the same for number 2 and number 3. Okay, great. Now that you are thoroughly confused, let's continue. All right. So how do we find the sine for a right triangle? We take the opposite leg value and we divide it by the hypotenuse value, and that's how we get our sine. All right, let's go on. Let's look at the cosine. The cosine is the ratio between the adjacent leg of an angle, a non-right angle, and the hypotenuse of the triangle. Hey, look, Mrs. Leon is texting my wife. Do you have what? I don't know what she says. Anyway, let's continue. The ratio between the adjacent leg of an angle, non-right angle, and the hypotenuse of the triangle. All right, so here we go. Okay, so here's our angle again. Here's our angle. And we are going to take the adjacent leg and the hypotenuse. So what is the adjacent leg of this angle? It is right there, okay? All right, so remember that the opposite leg and the adjacent leg are the ones that make the right the right angle in any triangle. So that's kind of easy to find out. All right, so for this angle though, the opposite leg is right there, so that means that the adjacent leg is this one. For this angle up here, this will be the opposite leg. We don't want that one. We want the adjacent leg. Okay? Once again, the adjacent leg and the opposite leg in a right triangle always make up the right angle. All right, great. So to find the cosine of any angle or the non-right angles in a right triangle, I need the value of the adjacent leg and the value of the hypotenuse, and I will divide those two. Okay, great. Now let's continue. Let's see. Let's do some examples over here. Haha, let's look at these right here. All right, so it says find the cosine for the 40-degree angle. Once again, this one right here, the 40-degree angle. Now, we kept really the same values from the last triangles that we used, okay? But in this case, we're using two different ones. All right, so we're going to take the value of the adjacent side, which is this one here. The adjacent side, and that is 5, and I am going to divide that by the hypotenuse, 6.53. That one right there. Okay, look at the other one. Here we have the 40-degree angle. I want the adjacent side first, 3.5. And I'm going to divide that by the hypotenuse, which is 4.57. Okay? Now, if these triangles are similar, then their cosines will also be the same. All right, so let's look at this. All right, so when I multiply, or when I divide, when I divide 5 by 6.3, I'm going to get 0.76. And when I divide 3.5 by 4.57, I'm going to get 0.765. Did I say that right here? I don't know what I said. 765. Good. All right, so that's it. That's how you find the cosine, okay? Now, the hardest thing about the whole thing is trying to remember which goes with which, or what formula goes with which one, the tangent, the sine, or the cosine, okay? So let's continue. Let's go on to the next page here. Yes, there is a page 2. Don't freak out about it. Now, you don't have to copy this down. You don't have to copy all of this down right here. Just copy this part right here. You don't have to copy all of it, so just copy this right here so that you have it all in one sheet of paper, okay? Those are the formulas that you need, okay? So, once again, the tangent, as it says right here, the tangent of an angle, the ratio between the opposite and adjacent leg of either non-right angle in a right angle, okay? So, once again, the tangent is, here's my angle, opposite leg divided by the adjacent leg, okay? The sine of an angle, is the opposite leg divided by the hypotenuse. So let me use this one. There's the opposite leg, there's the hypotenuse, okay? And then for the cosine, let's use this one right here. The cosine of a non-right angle, so the cosine will be the adjacent leg divided by the hypotenuse. In this one, it will be the adjacent leg divided by the hypotenuse. Great. So, as long as you can remember that, you will be okay. All right, so just make sure you copy. Tan equals this. The sine equals that. And the cosine equals this right here. And those are the three ratios found in every right triangle, okay? So every right triangle will have all three ratios. All right, to finish up this morning, this afternoon, this evening, this middle of the night, you know, some of you guys need to stop playing Fortnite so much. You guys are staying up way too late. I took another drink of my Slim Fast. Woo! I love this stuff. All right, let's continue. So let's look at the tan. How do we find the tan? So this is the angle that we're going to be using right here. The tan for that angle is 5, all right, the opposite side divided by the tangent. So that gives me 0.91. That is the tan or the tangent for this angle in this particular right triangle. What is the sine? And by the y is Gomorrah. Got another one for you. Where is Gomorrah? All right. The sine is abbreviated SIN. It's not pronounced sin. No, that's what you have. You are a sinner. It's still pronounced sine. Anyway, so the sine tells me that I need the opposite leg divided by the hypotenuse. All right, so that's why I have 5 divided by 9.5. And then the cosine, the abbreviation for the cosine is cos or cos, is the adjacent leg by the hypotenuse. Okay, and so it's 0.58. All right, so for every triangle, you will have all 3 ratios found within that triangle. Great. Now, in your 18.2 worksheet, which is, where is it? Right there. It's page 263, right here. 263, 264, and 265. You will have to find the sine and the cosine for each one of these triangles that are given to you, okay? And so you will find the sine for these two, and then you will find the cosine, and then you will find the tangent for each one, okay? So just read those carefully. Here as well, you will do that. You will be allowed to use the calculator, right? You can use the calculator. And in your textbook, chapter 18.3, it tells you how you can use your calculator. There's a small section that tells you how to use the calculator to get those problems. And then at the end, you have some algebraic expressions to work on, okay? So for those, you just need to look back at your notes and you shall be fine, okay? So remember, in these problems here, what we want to do is isolate the variables, right? Isolate the variables, and so on. So just go back in your notes and work those out, and we should be okay. All right, so make sure that when you get these done, please make sure that you text them to me or send them by email to my email, Christian Preacher 05 at yahoo.com. Okay, so make sure you send it there, and like that I can have your work and not give you a 0. Once again, no work for some of you. Not gotten anything from some of you people, and I will not name any names, but you will not get a good grade on this if you don't turn it in quickly. All right, guys, we're gonna leave it there for today. That is the sine and the cosine, and just a quick review of the tangent of a triangle. All right, great. So later on in the week, I am going to put a short video of problems with right angles, sort of like that, in which you will have to find the tan, the sine, and the cosine for each one of those triangles. All right, but that'll be later on in the week. Don't worry about it. You know you love me. Don't roll your eyes at me. I'm trying to keep you busy because, hey, you are bored at home, right? All right, you know you love me. Okay, guys, we'll leave it there for today. I hope you have a good day, and I will see you in the next video. Bye-bye.